we left here yesterday. Let me get rid of this. Look at question number 1, part E. It says find the equation of the tangent to the curve of this equation at point -1, 2. So equation of tangent at point -1, 2. Let me copy this equation first. 12f and question number 1e. Equation is y is equals to 2x cube plus 6x plus 10, and we have to find the equation of tangent at point -1, 2. So whenever you listen this word tangent, it is equals to dy by dx, or it is equal to m, the gradient. So for any equation of straight line, we need gradient and point. Point is already there, so let me find the gradient. So dy by dx is 3 2 times is 6 x square plus 1 into 6 is 6 and 1 minus 1 is 0, so we get rid of this x. This is our dy by dx at x minus 1. When x is minus 1, gradient is 12. Now we have the gradient, we have the point, and we can go for y is equals to mx plus c. Y is 2, gradient is 12, x is minus 1, c is unknown, so 2 is equals to minus 12 plus c. 2 plus 12 is equals to c. C is equals to 14. So finally the equation is y equals, gradient was 12x plus 14. So equation of tangent at point -1, 2 for this equation is this. Theme will always be the same and only equation will change. For example, x square minus 7 over x square. Another question. Question 1, part F, and it says y is equals to yes, I'll go. Okay, just let me write this and expand it. Y is equal to 12x plus 14. Any issues? Another example, we are given with the equation and find the equation of tangent at point 1 comma minus 6. So before I go into dy by dx, depending on my practice, there's no restriction. I always write it in this form first. Then dy by dx is 2x minus 2 into minus 7 is plus 14x. When you subtract 1 from power, it becomes minus 3. I'm simplifying it, and it becomes 14 over x cube. So I need to know the gradient when x is 1. So 2 into 1 plus 14 over 1 cube. 2 plus 14, 16. I know the gradient, I know the point. Y is equals to mx plus c. Solving for c, y is minus 6, gradient is 16, x is 1. So minus 6, 16 plus c, minus 6 minus 16 is equals to c. C is equals to 16, 4, 22 minus 22. Finally, writing the equation y is equals to mx plus c. Got it? Let's try some longer questions. Question number 3 says find the coordinate of point where the tangent of the curve this at point this meets the normal to the same curve at point this. So these are two different stories. We'll go about them one by one. Are you getting disturbed with the noises behind me? You sure? If there are, I can close the door. Okay. Okay, question 3 says find the coordinates of the point where the tangent to the curve y is equals to x square plus 1. Y is equals to x square plus 1. Tangent at point 2 comma 5 meets the normal to the same curve at point 1 comma 2. Y is equals to x square plus 1 normal to the same curve at 1 comma 2. Understand this question first. This is the curve x square plus 1 roughly at x2 y5 there is a tangent and it says find the point where the tangent this and point this meets the normal. Okay, so firstly we know the equation and we know we have to find the tangent at the given point 2 comma 5. For the same curve it says the normal at 1 comma 2. So let me say this is 1 comma 2 and at this point this is the normal. And where does it intersect? It intersects right here. So we have to find this point. Before we solve that, I need the equation of tangent and normal. So summarizing them neatly, equation is y is equals to x square plus 1 and I have to find the equation of tangent at 2 comma 5. When I listen or read the word tangent, I know we have to go through dy by dx. So dy by dx is equals to 2x. At x2 the gradient is 4, right? We know the point, we know the gradient, so we can find the equation of tangent, that is y is equals to mx plus c. Y is given, which is 5, gradient is 4, x is 2 and 5 is equals to 8 plus c. 5 minus 8 is equals to c. C is equals to minus 3. So equation of tangent is y is equals to 4x minus 3. This is equation of tangent. Now I'm going for equation of normal. Data is same. Y is equals to x square plus 1. Dy by dx. Why am I doing it again? Because it is for the different point, 2x, and now it is at 2 comma 5. Sorry, 1 comma 2. It is at 1 comma 2. So when x is 1, we know that the gradient is 2. For the tangent, what about the normal? So it is m1 into m2 is equals to minus 1. First gradient is 2, second gradient is unknown, so m2 is equals to minus 1 by 2. Now I know the gradient, I know the point, I can go for y is equals to mx plus c to find the equation of normal. So y is equals to mx plus c, y is 2, gradient is minus 1 by 2, x is, yes, tangent and normal are always perpendicular. Always. This is tangent and this is normal. When they are perpendicular, you call them normal to that tangent. This is tangent to the curve, this is normal to the curve at the same point. So simplifying, 2 minus 1 by 2 plus 1 by 2 is equals to c. So c is 5 by 2 and the equation is y is equals to negative 1 by 2x plus 5 by 2. This is the equation of the normal and this in red is the equation of the tangent, and we have to find the point of intersection. So bring them closer. First equation is y is equals to 4x minus 3. Second equation is y is equals to negative 1 by 2x plus 5 by 2. When we have these equations, we can solve them either by elimination or substitution. I am going for elimination. So I'm subtracting these equations and changing the signs. Yes, Momo. That was the previous equation. y is equals to 2x. Where did you see that? Why is it? No, that's dy by dx equal to 2x. That's gradient. Okay, this was the question. This was the question. Equation. When you took the derivative, it is 2x, right? And at x is equals to 2, the gradient is 4. Now we have the gradient. This is the gradient, and we have the point 2 comma 5. Using both of these, you found the equation y is equals to 4x minus 3. Right? Next case, we have the same curve, but we need to find the equation of normal at 1 comma 2. So using the same curve right here, differentiating it to find the gradient when x is 1, and we found that the gradient is 2. But this is the gradient for the tangent. dy by dx is for the tangent. So what about the normal? For the normal, we use this formula m1 into m2 equals minus 1. So you got the gradient for the normal. Now you have the gradient for the normal as 1 by 2. You have the point 1 comma 2. We have both of these things. We use the point and the gradient in y equals mx plus c to get the equation, which is this. Now the statement question said that find the coordinates of point whose coordinates where the tangent to this curve and the normal meet. So we found the equation of tangent first, then we found the equation of normal, and now we are going to check where they are intersecting. And how will we do that? We can solve these equations simultaneously, either by substitution or by elimination. And I'm not blaming anyone, but a part of that depends on not practicing. A slight part of that. Do you remember when in the last class I said when we will move on to the next questions, we will be discussing cases, and we won't wonder on how to differentiate it, where did it came from. We can slow down if you wish. Whenever you have test, you can let me know, so we'll plan our class accordingly. For now, solving these simultaneous equations, when you add these, we get rid of this y. 4 plus 1 by 2 is inshallah. Inshallah. So 3 into 2.5, 3, 4, 5, 5.5. Solving this is 5.5 over 4.5 is equals to x. X is equals to 55 by 45. When we divide it by 5, it is 11, 9. So x is 11 by 9. And put it in any of the equation to find y. So y is equals to 4 into 11 by 9 minus 3, 44 by 9 minus 3, 9 LCM, 44, 9, 3 times is 27. So 30, 10, 14, 15, 16, 17 by 9. I hope it is correct. Can someone check it quickly? 17 by 9 is equals to 4 into x was 11 by 9 minus 3. Can you see if left hand side is equal to right hand side? Thank God. So this is our answer. Let's try a few more questions. Okay, let me cancel out this free space. Why did I leave this all the way? Okay. Okay, next question says find the equation of the normal to the curve this at point this and this. So finding the equation of normals to this curve at point 0, 0 and 1, 2. Be careful, this is normals. First we'll always find the gradient of tangent, then from that we can go for the normal. So this was equation of normal to y is equals to x plus x cube at point 0 comma 0, and the other part of this question is 1 comma 2. I think it's getting loud. Please let me close the door. Just a second. I'm back. So we have to find the equation of normal at these 2 points. So first thing, dy by dx. Gradient of dy by dx of x is 1. 1 plus 3x square. So at 0 comma 0, 1 plus 3 into 0 squared is 1. At this point the gradient is 1. At the other point, when x is 1, dy by dx is, or we can go 1 by 1. Gradient at point 0 comma 0 is 1. So m1 into m2 is equals to minus 1. First gradient 1 into m2 equals minus 1. So second gradient is equals to minus 1. So now we know gradient of normal is minus 1. Gradient is minus 1 and point is 0 comma 0. We have to find this equation. So y is equals to mx plus c. Y is 0, gradient is minus 1, x is 0, c is equals to 0. So y is equals to minus x. This is the equation of normal at point 0 comma 0. Now for the next point, y is equals to x plus x cube. Dy by dx is equals to 1 plus 3x square. I'm actually copying it from the previous working. Now we need to find the equation of normal at 1 comma 2. So the value of x is 1. You get the gradient 4. m1 multiplied by m2 is equals to minus 1. First gradient is 4 into m2. Gradient of the perpendicular or the normal is minus 1 by 4. We know the normal. We know the point is 1 comma 2. So we'll find the equation. Y is equals to mx plus c. Y is 2, gradient is minus 1 by 4, x is 1, and solving for c. So 2 plus 1 by 4, c is equals to 9 by 4. So finally y is equals to mx plus c. Either leave it as it is or rearrange, multiply the whole equation by 4 minus x plus 9. So these were the two equations. Any problem till now? Are we still missing here? Now see, this wording keeps on changing. The structure is same. Y is the equation. Dy by dx is the gradient of tangent. m1 into m2 is equal to minus 1 for the normal. Then it asks you the equation of straight line, and for equation of straight line y equals mx plus c. You need two things. You need the point, it comes from the question, to find c, and where do you get the gradient? If it is tangent, you get it from here. If it is normal, you get it from the second equation. Question number 5 says, for the given equation, find the equations of tangent and normal at the point where x is equals to minus 1. So at x minus 1, we need to find the equation of tangent and normal both. So question number 5. F of x is equals to 12 minus 4x plus 2x square at x is equal to minus 1. Now before we begin, we know that, okay, let me drag it here. Question number 5, f of x is equals to 12 minus 4x plus 2x square when x is equals to minus 1. We know what we have to solve. We have to find the equation of tangent and normal. Before we start, we know for tangent we will need a gradient and one point x comma y. For normal, we need the gradient and one point x comma y. We will go about the gradients, but y is also missing. So first let me solve for y. When x is minus 1, 12 minus 4 into minus 1 plus 2 into minus 1 squared. 12 plus 4 plus 2. 12 and 4 is 16 plus 2 is 18. So we also have the coordinate minus 1 comma 18 for both of them. We know the coordinate, and now we'll find the gradients. F of x is given 12 minus 4x plus 2x square. F dash x will be constant, goes away, minus 4 plus 4x. At x minus 1, the gradient will be minus 4 minus 4 minus 8. The gradient will be minus 8. Now the first gradient, the dy by dx, is always for tangent. I know the gradient for tangent, I know the point for tangent, I can find the equation. And at the same time I'm finding the gradient for the normal. So minus 8 into m2 is equals to minus 1, and m2 is equals to minus 1 by minus 8 is equals to 1 by 8. Now I can say that for the tangent, gradient is minus 8. For the normal, gradient is plus 1 by 8. For the tangent, the point is, what was that, minus 1 comma 18. Minus 1 comma 18. This is minus 1 comma 18. We had the equation. In the equation we substituted x to find y first thing. So we have x comma y. Now we needed the gradient, so we went for dy by dx, that is f dash, substituted x, and you get the gradient of tangent. Using this tangent's gradient, you find the gradient for the normal. Now for both of them we have the gradient, we have the points, and you can go for y is equals to mx plus c. Y is 18, gradient is minus 8, x is minus 1 plus c. 18 equals 8 plus c. 18 minus 8 is c. C is equals to 10. So equation is y is equals to mx plus c. First thing. Second, y is equals to mx plus c. Y is 18, m is 1 by 8, x is minus 1 plus c. So 18 plus 1 by 8 is equals to c. So c is equals to 8, and 18 into 8 is 144 plus 1, 145 by 8. Second equation is y is equals to mx plus c. 8y is equals to x plus 145. So equation of tangent and equation of normal at point when x is minus 1. Getting it? Inshallah you'll get it, inshallah. We'll plan another practice test as well, and this time I'll coordinate with you. I'll coordinate with you. I don't want to make it tough for you, but I want you to practice. we, we can narrow down the scope. For example, just one topic, and the very latest or second latest, so you don't have to actually go around it, and everyone else outside the class is happy. Getting it? But this is the fact. If you practice this, you'll score. Definitely, if you've forgotten, then no one can like guarantee anything. Okay, this thing is show that it is increasing or decreasing function, as we just went over it in the last class. Increasing functions are those when the gradient is positive. Decreasing functions are those when the gradient is negative. So for the given values, one function could be increasing and decreasing both. For example, y is equals to x square. If we sketch the graph of y is equals to x square, this is the graph. And if you draw the gradient on right hand side of 0, that is x is greater than 0, at any point, this tangent in blue will be positive, this tangent in green will be positive. So you draw this tangent at any point, the gradient will be positive. So it is increasing function. You see the values of x are, when you put the values of x, the values of y are increasing with the increasing value of x. But on the other hand, the gradient is negative, and this is the decreasing function. When you increase the value of x from, let me say, minus infinity, the value of y is actually decreasing until you cross this point 0, because after 0 the gradient is positive and the curve is rising. And in case of cubic function, let me name these points a, this b. I can say that before a, or let me say a, let's rename them for ease. C, A, B, C, D. I can say from A to B the function is increasing. From B to C the function is decreasing. From C to D the function is again increasing. Now you see, wherever you draw the tangent, you will get a positive value from A to B, wherever you draw it. From B to C, you'll get a negative value of the tangent. From C to D, again, you'll get a positive value of the tangent. So increasing functions are those whose gradient is positive. Show that the function this is increasing for all real values of x. So let us copy this as f of x is x cubed plus 24x plus 3. Just a second. Assalamu alaikum, sir. Walaikum salam. Sir, may I call you back in like 20 minutes? नहीं सर, मैं क्लास में हूँ, वो घर है. अल्लाह हाफिज़. Sorry about that. Okay, I'm going for differentiation. Why? I need to check if it is increasing or decreasing. So f dash of x is 3x square plus 24. Do you agree with this or not? Till now, is this differentiation correct? Is this differentiation correct? So at any value of x, whatever we substitute here, will we get a positive or negative answer? 3 times something whole squared plus 24. So whatever you substitute in this x, what answer will you get, positive or negative? You're really thinking about it? You have this square on it. Whatever you substitute in this, a negative value or anything, it doesn't matter. It is always positive. So the value is always positive, the gradient is always positive, so yes, it is an increasing function. Wait until you get your practice test. This isn't a practice test. Wait until you get one. Find the interval on the function. Find the interval on which the function this is decreasing. Okay. On which it is decreasing. So first we copy this function. F of x is equals to x cube plus 3x square minus 9x. Now he needs to find us the interval on which the function is decreasing. These are the two hints. Interval is unknown, but one thing is given, the function is decreasing. Whenever it is increasing or decreasing, we find f dash x, that is 3x square plus 6x minus 9. Differentiation done. The examiner requested that the function is decreasing. If the function is decreasing, it must be negative, right? So if it is negative, it is less than 0. I'm solving this. Dividing the whole equation with 3 is x square plus 2x minus 3 is less than 0. And going for midterm breaking is 3x minus x minus 3 less than 0. X, take out x common, x plus 3 minus 1, x plus 3, so x minus 1 and x plus 3 is less than 0. Be careful, this is not the final answer. Always you have to check it. X is less than 1 and x is less than minus 3. How do we check it? You write these two values here, minus 3 and 1, and check for A, B and C. In case of A, may I try minus 4 in this region? So in your main equation, try this. When we substitute minus 4 squared plus 2 into minus 4 minus 3 is less than 0. So 16 minus 8 minus 3 is less than 0. 16 minus 8 is 8, 8 minus 3 is 5 is less than 0. Is it true or false? False. This is false, so region A is not selected. Region B, between minus 3 and 1, I am selecting a value 0. Using the same equation, 0 squared plus 2 into 0 minus 3 is less than 0. These both are zeros, so minus 3 less than 0. Region B is correct. Checking for region C, I am using the value 2. So 2 squared plus 2 into 2 minus 3. 2 square is 4 plus 4 minus 3. 8 minus 3 is 5. 5 again is not the region. So the only values where this is less than 0 is minus 3 to 1. So minus 3 is less than x is less than 1. For this interval, the function is decreasing. If we connect our previous knowledge, we now know that at minus 3 and at 1 it is decreasing. So I can say this is the case. On all other situations, it would be increasing. So this is my sketch as well. We can be more specific if we find the value of y at the turning point. For now, it is not the requirement, hence leaving it there. Okay, quick summary. We'll stop it here. We'll stop this here. Find the values of x for which it is an increasing function. So what do? dy by dx greater than 0. Question 2. Find the values of x when it is decreasing function. So dy by dx less than 0. Question 3. Show that the function is decreasing. for all values. So dy by dx, and yes, using any value or stating so that we use any value, the square will turn it into a positive value. Given that the function this is increasing on the interval this, when you have this bracket, this means it is from -1 to 1. Find one possible value p. Okay, let's try. This is a bit different question. So f of x says x square plus px. F dash x would be 2x plus p, and it says that it is increasing on the interval -1 to 1. -1 to 1, it is increasing. So find one possible value of p. X is from -1 to 1, and 2x plus p is actually greater than 0. 2x plus p is greater than 0 because it is increasing function. So you can use any value of x between these. An interesting value is 0. So when we use 0, one of the possible value of p is that p is greater than 0. And one more thing which we can say is that 2x plus p is equals to 0. So 2x must be equal to minus p, and x is minus p, 2x. So we can use these values here, and we can also get the range of values of p. At -1 it would be -2, at 1 it would be 2. So value of p actually ranges between -2 to 2. So you can write any value of p to justify this question. We'll stop here for today. If you need to ask anything, you may. Please go through okay, Mohammed, look at this. This is dy by dx. What if I ask you to differentiate 15x square? This is actually the same nature. If you differentiate this, you get 15x square, right? When you differentiate 15x square, again you get 30x. So differentiation is always there. But why are we doing d square? Y over dx square? That will be our second point of discussion. So base stays there. The nature of the question stays there. You should only know how to differentiate it. So go through that. Inshallah, you'll be good.